16 inches, and so the model number of this, wait, I'm with a number. So this is 2485, and it's coming in for no backlight. So a bit of a background of this. I'm not sure if you guys can see that. Can you see that? Can you see that? Okay. So a bit of a background to this. So this was assessed, and then the technician thought that the issue was screen related. So they basically decided to order a new screen, and then the screen arrived, and the state didn't change. It was still an issue of no backlight. So, but then I can I would say that getting the screen was a form of speculation. There was no facts, or there was no data to back up to back it up to say, okay, this is why, or the issue is, okay, all of my assessment is done. I have used my multimeter and everything, and all of the assessment shows that this is a screen issue. So they replace the screen, and the problem is still there. So which just meant that the problem was never the screen. So it's definitely an issue on the main board. So yeah, we are now going to take the board out and get to understand what's going on, and then we take it from there. So first thing first, let's take out the back cover. It's important when you're taking out the back cover to try as much as you can to be as close, so to have full control of your screwdriver as much as possible. For example, if you're doing this, for example, you have little control, and the chances of your screw slipping onto to create a scratch on the cover is very high. So you try as much as you can to be as, basically as close as possible, and also to make sure you have full control of your screwdriver. So let's start. Okay, screws are out, and then as you guys know, after the device is still on, the first thing we're going to do is to disconnect the battery. So for this one, from 2016, Apple had this dual battery communication design, where you have the main battery power line as well as the data line. So in the 12 inches, they had a similar design, where a battery, where they had to use a screw to basically hold the battery in place, to basically hold the screw to hold the body in place. But in that design, there was no separate, a physical separate cable data for the battery. It was just, so what I'm trying to say, so now we have this. This is for the battery. Okay, let me try to review that. So by the way, once that cable is disconnected, there will be no longer, now the power coming from, basically the power coming from the battery to the machine will get disconnected as well. So let's take the screws out. We're using a T2, a T4 screwdriver, sorry. Oh, by the way, the 14 inches, this is important, Peter, the 14 inches, you should know that they do not have the same trackpad connector on the board, which means you don't share the same trackpad, depending on if what you have, it's a max or a regular. No, you know the 14 inches. So you have the max option, and then you have just the 14 inches. So you have the base function. So I'm just gonna so can you get that 14 inches, the one that is there? Yes. So it's something that, in case you basically want to. So, um, just gonna take this out. And then also, when you look at the heatsink and then obviously the heat spreader, that can also, it's more like also a giveaway to know if this is a max or regular. So you see how this is, wide? Yeah. Okay, I'll show you that. I'll show you the other one. Let's have the, let's have those. Yes, all of it. Okay, so now you see, can you see this? First of all, you see the difference in your heatsink. Yeah? Yeah. Now look at the trackpad connector. That is small compared to that. That is wide. Yeah. Even though it's still a 14 inches. Now let's see if we can. Now if you check the board number here, the board number will be 820-02481, and then this is going to be 820998. Now you have a small connector, so which would then mean that if you obviously, if you're swapping this for that, for example, then you have to consider getting another trackpad cable. What we have not confirmed is if you have to replace the entire trackpad assembly, which is basically to get an entire trackpad and as well as an entire trackpad cable. But one thing I can say is the fact that the trackpad for this, even though the same 14 inches, so you see this, for example, so this is the bigger one also. So this is basically, and then you see that. So you see, so basically one of all of these are the same thing. So what we have not, what we are yet to confirm is if you have to, but what stands out is you just need to replace the trackpad in order for the trackpad cable in order for that to be, so if you choose to replace the board for a different configuration. So that is that. And let's then just go back to where we were. Please do close that, and yeah, you can put that back. Okay, so here let's come back to, so now you see here, these are the two cable system that I'm talking about. You have the data cable, which is this here, and then you have the main battery power line. So this is the main battery power line, and then basically this is your data cable for the battery. Now in order for you to disconnect power going to your machine, with the cable disconnected, you should have no power going to your machine basically. However, if what we have also seen, it's with Chinese batteries, even with the battery disconnected, you don't, there is because of improper configuration, even with the data cable disconnected, you will still have the battery being actively supplying power to your board. So but that is for Chinese battery, but that's so yeah, that's just that on that. So yes, now we have basically so that is about the dual battery connection system. Now we're here to, so before we take the board out, we could just see what is it that we have on our backlight output. Yeah, let's actually do that. Let's see what we have on our backlight output before we take the board out. And by the way, there's been a huge shift in the backlight design of the old and the new. So with the old ones, okay, we will go to that quickly. Let's just do this. 02100. So let's open up the board view. 02100. So 02100. Okay, here you go. It is 02100. That's your 16 inches. And this is going to be our backlight section here. So I'm just gonna on previous designs. So let's go to our schematic. So it's 820-02100. if we go to the section of the backlight circuitry, so let's go to JP 9000, or we can just go to CP 830. So let's go to CP 830, CP 830. Now, if you see here, this is the maximum, this is the voltage out. It says what? 15 volt. Now that's a huge difference between 55 volt of previous designs. For example, the same 16 inches 2019 Intel. Let's open that up. Same 16 inches 2019 Intel. So let's just open that on the others. So let's come here. It is 00001,700. Let's say, do we have it? Okay, there you go. Now this is a 16 inches, and then the backlight output is going to be, let's say, okay, that's your backlight. It's a backlight line. Okay, now let's open up the schematic. Here you go. So we are going to check for C. These are the backlight. These are the caps on your backlight output line. Let's go check out C8466. So C8466. Wasn't typing. Yeah, I really need to reinstall my machine. It's really acting up. Okay, so let's open that up. Let's try close that off. Where are we? 01700. 01700. Let's see. I'm looking for the 16 inches. 01700. Do you see it? 01700. Do you see it? Okay, we can just type. 0-01700. Okay, so there you go. And what's the cap again? See what? Okay, let's just check. So 8466. Now, if we check the same backlight output, see what we get in. 59 volt. And this was the design. This was the Intel. This was the 2019 design. However, with the newer designs, you're getting considerably lower voltage output. So, I mean, so okay, yeah. Let's not delve too far into that. So that's just basically, so in case you are measuring for your voltage output, and then you see, for example, 15 is going to be like the max when your screen is at its brightest. That's going to be 15 volt. But so you probably be getting 13 to 14 something, depending on how bright your screen is. And then also with the i9 as with the Intel as well. So 59 volt, that is the max brightness of your screen. You understand? And oftentimes, yeah. So, but just so in case if you're troubleshooting these machines, whether it's the 14 inches or the 16 inches, by the way, it's not the same with the M1 with the Intel with the 13 inches M1s. So with the 13 inches M1s, for example, so let's go to E20. Okay, let's see. The 13 inches. So let's open up. So this is so that's going to be our M1 MacBook Pro, and then the backlight output. So your backlight output is going to be, let's say CP870. CP870. Let's open up the schematic. So 80.0.2020. It is 0.0.2020. Okay, there you go. That's your M1. So it's CP870, yeah? CP870. Now, here, what's the number? I don't see the number yet. You see what you have, 55 volts. So the change was only from the 14 inches and the 16 inches, like the 14 inches and the 16 inches. So the 13 inches M1s, they still basically follow the same trend as the previous design, 55 in terms of the previous design. Okay, so now let's go back to, the reason why I'm pointing this out is in case you're measuring for your backlight and then you see a considerable drop of your backlight output, then you wonder, oh, is this a problem? No, it's not a problem. So there's been a shift in design in terms of what they used to, what the voltage output used to be and what it is now. So now let's come back to our board view itself, which is going to be, where are you? 2100. Okay, yeah, this is where we are. Okay, so we are at the voltage out, the backlight page. And so let's see what is it that we have. First of all, let's confirm that our device is on. Okay, the device is not on. Let's connect power to it. That's a Max F3. Okay, the device is coming on. That's the Apple logo, but we don't have a backlight. So the next thing we're going to do, I'm not sure if you guys can see that. You still getting the light there. So how is it? I thought you said you don't see it.
Only an M4 I can use here. But if I want to see something like a
yeah. Okay. Okay, so now let us see what is it that we have on our backend output. Let's go back to our board view, 2100.
macOS contains a built-in screen reader called VoiceOver.
So we can measure for our backlight at CP830, and that will be this guy here. This guy here, this one, CP830. So CP830 will be this, and then CP834 will be this guy here, and then this will be CP830. So which will mean, so basically this and that, they are on the same line. So it will be fine to basically place yes, the multimeter probe there without having to be worried about bridging anything. So our voltage is set to 20 volt. So we have our black probe put on ground, and then our red probe. Let's see here, what do we have? And we have 0 volt. Okay, so the next thing we want to do is so we have 0 volt, and that tells us that there's nothing happening there. So with 0 volt, the next thing we are then going to confirm is if we have a short on our backlight output. So you have to understand that 0 volt will basically mean that there is no opening at all. So here you're supposed to have PP bus voltage. So the design is the same as the previous design, in terms of the layout. So here you have PP bus voltage coming into the circuitry, and that is what is going to basically power your PP bus, and then that's what's going to power your backlight. And then you have UP800, which is going to do basically the boosting. So this is going to basically this is where the boost controller, which is a DC to DC boosting, will take place. UP800. This is a backlight IC. Now the backlight IC obviously will require, so this has to be present. Now in order for this to open, in order for this circuitry to open, the fact that we are getting 0 volt here, it means that basically this is not opening. It means that this is not opening. So what you now want to find out is why that is not opening. The first thing we want to confirm is to see if we have a short on your backlight output. So we can use our multimeter here. So we basically leave this to be on continuity mode, and then this will be on voltage as well as a diode mode. So let's see continuity mode. Let's see if we have any short. We make sure that the batteries is connected. let's see. This is definitely ground, and then the other side, we have OL. Okay, so OL. Now the next thing, let's also use our mode. Let's use a diode mode to also see what is it that we measure there. 050540. Okay, let's disconnect the screen, and then also then we disconnect the screen and compare it to another board to see if and by the way, when it comes to when it comes to especially your backlight measurement, it's very your backlight output measurement, it's very good to use diode mode because that gives you a better idea of what is happening. So you see, when, for example, when we use our continuity measurement, which is called OL, but when you use your diode mode measurement, you will get a better picture of what is happening on the board. So with the screen disconnected, let's see what we have now. Okay, it's a little high, obviously, because there's been load lifted from the line. Let's now compare that with another board. Can we have any of those? All of it? Let's see, we're gonna use, we will obviously need the one that still has a backlight IC on it. That's all. Backlight IC, it's gone. Okay, still, we still have a backlight chip here. Okay. Okay, it's also gone. So behind, so the two boards like this behind the iMac. No, not those ones. This boards that you just gave me, you find two like that. Thank you. So we want to use the one that has the backlight chip still on. So this is your backlight chip that is still on, and then the other one, backlight chip is still on. Okay, great. So so we are going to use that as a comparison. So let's use that as a comparison. See what we have. And by the way, when it comes to diode mode, your red probe has to be what goes to ground, and then your black probe becomes your what you use for your measurement. So let's see, what do we have? 640. That's about the same thing, yeah. So that's fine. So we don't have a short. So the next thing we want to do is to take the board out to get to understand why we do not have a backlight. So we will be basically going to the backlight circuitry, which is the backlight driver. And then, by the way, whenever you are taking your screws out around the battery, it's important to guide it because the chances of the screw slipping and then punching your battery is very high. And then once you punch your battery, that's basically a very beautiful way of destroying your own battery. Do you understand? So it's always good when you are taking screws out close to your battery to guard your screwdriver. Because chances of it slipping it's very, very high. It's got a lot of, this machine's got a lot of screws. Now, when it comes to troubleshooting your backlight, there are many considerations. There are many steps to go through. However, with this particular machine, when you have issues with your backlight, the first thing you actually want to do is to go to the backlight circuitry itself. Because we have really seen that oftentimes you get the backlight chip on this ones. Oftentimes they fail, sometimes due to liquid, uh, and other times they just fail without anything to point to say, okay, this is why it's failed. So we tend to start from there and then move our way from there. Need C6. Then we need a different screwdriver type there. It's going to be 3.0, I believe. It's 4.0. Let's try. No, I think it's 3.0. Not. Okay, let's try 3.0 first. It's 3.5. Okay, let's just try 4.0 first. Yeah, that's it. It's 4.0.
You don't want them out.
Second.
Them out.
Say that again.
Usually I struggle with this.
Okay. Now all of our screws are out. Now it's time to disconnect the cables. Whenever you're using a tool, make sure you have full control over your tool. Do not allow the tool to take control. Otherwise, you may make catastrophic mistakes, which is going to basically go beyond the primary repair. And the idea is to use your fingers more than the tool itself. Whatever, as much as possible, you use it. So yeah, so now that is done. So in terms of taking the board out, so you want to look at where you have basically a way out. So for example, we know that the HDMI port extends through the chassis, and then here we don't have anything. So which then means we don't have anything that extends out here. So all of these are cables. So which means the board going out will go out from, so this, it has to be lifted from this section here, not from here, because when you try to lift it from here, this will prevent it. You understand? So rather you lift it from this side, because here you see there is no extension of this here. However, this does have an extension into the chassis, so we do the lifting from this side. Obviously, after you will ensure that all of your cables are disconnected. And when you're taking the board out, just to be careful not to force it out in case there's still any cable that is not disconnected. You don't want to break any of the cable, especially the touch ID. It's a nightmare when you have the touch ID broken, because now you have to run wires across it. Okay, so that is that. Let's see what is our board like. If that is too far, you can always put it there. It doesn't have to be that side. We're busy with it. So what we're now going to do is we're going to go to the other side of the board, and yeah, what you say? So this is the section of the backlight, and yeah, we definitely have a problem there. And but this time is not. This doesn't. I don't. I really don't get it with this with this particular design. Exactly. This is this I don't know. And for some reason, oftentimes I don't know. I don't know. It's just something that. Okay, so yes, I mean, this is definitely going to be our problem. So as you guys can see, we have a bit of liquid remnant here. How that came to be, ask me if I know. So the components that seem to be affected is we have one, two, three. Those are going to be. Let's go to our board view. Flip the board to the other side. So the companies affected are this, which is ROP 833, and then also you have this, which happen to be sitting on the same line, ROP 870 and ROP 840. So those are the initial. Those are going to be our initial section to attend to. And then hopefully we don't have to replace the actual backlight itself. Hopefully nothing, there's nothing underneath the backlight itself. So I'm basically I'm referring to the backlight chip, which is this guy here. See the pad on one side is definitely affected. These two look okay, but just to be sure, okay, that's fine. So we can reuse that. Let's see. Okay, also that is fine. So the only problem seemed to be, okay, let's see that. Okay, so that seemed to be the problem there. That. So which is so the pin 2 of RP, so the pin 2 of RP 833, that pin 2 of it is definitely an issue. Let's see. Okay. Okay, so let's first of all, let's try to address the pad, and then we have to, so we can reuse the other two. Okay, let's get can we have one of the board? The board, one of the board. Yes. You're not following up with what we're doing. Okay. Um, the other two. Okay. Yes. Yes, we did. We took everything from here. But what about the other two that were here? I don't. Remember the small ones? We have placed them somewhere around here. We don't see them.
It didn't.
Ah. Okay. Okay. So I was basically gonna, you know, transfer those back here, but it's okay since we can find them. Uh, Now let's clean that section of the board. We hope that's going to be the only repair. We hope we don't have to replace the actual backlight IC. Okay. Let's hope that solves our problem. Let's put the board back in the shell to see if let's have the shell. And to install the board, you have to obviously do the same thing. Remember, you install the board by doing you took the board out by doing this. To install it, you have to do the same thing. Because if you start from here, you may struggle to put that in. Make sure all cables are out. We're not necessarily going to have all of the cables connected. We are only going to connect the ones that we need for the testing, which are going to be basically the screen cable, the battery, and the DC jack. We'll need the DC jack, which is the MagSafe 3 connector. Okay, that's in its place. We will need trackpad. Yeah, I can just, yeah, we need the trackpad. Let's get the battery screw. Try to make sure it's properly aligned. Okay. And then another thing. So oftentimes, not oftentimes, but sometimes when you work on these devices that have the dual battery connection system, it may the data cable on the other side may have moved the side.
Oh yeah.
You understand? May have moved, and because you didn't remember, you didn't actually, you were not here. So what happens sometimes is after the repair, your battery is no longer detected, and then you ask yourself, oh, why is my battery not charging? Why is my battery not detected? So just to make sure that, just always try to just make sure that you have proper connectivity on the other side as well. It's interesting because even though you didn't actually go there, but you find that you have an issue on that side. Okay, so that is that. We just, okay, let's connect the fans. We need the fans. One fan, it's okay. Okay, just one speaker to enjoy the welcome sound. What else? Pretty much, yeah. Now we can, and then also, so when you are using with your battery cable, so just be sure not to use this to bridge any of the lines. Just to be safe. You can use this to basically guide it, but not to bridge the actual line. Okay, so that's done. Now we can connect. Okay, the device is started. So remember the first time we were getting 0 volt on our backlight output. So right now, as you guys also know, just like how we don't like the fan spin to be our get to know whether the repair was successful or not. It comes also backlight. We want to see what is the backlight output. So that is what, before we flip the screen, let's first of all get to know what is the backlight output. So that will give us an idea if we made progress or not. So before we flip the screen to see what the issue is. So yeah, let's see. And by the way, another thing you notice is the fans. Yeah, devices all we know. Fans. So fans are not spinning, obviously, waiting for the CPU to get hot before it spins. So our black probe is on ground, and then our red probe. Let's see what we measure on our backlight output. 14.6. That's beautiful. We have backlight. Okay, now I can flip my screen because now, I mean, the multimeter said we have backlight. We definitely have backlight. So let's see. Alhamdulillah. That's our backlight. So what we're going to do is we can just, wait, okay. We can set that up. Oh yeah, the keyboard was not connected. Okay. But wait. Let's see this. Let's just do this. Okay. But then we need to wasn't it connected? Oh yeah, the angle sensor also not connected. Ah, I see what you're saying. Continue. Let's just continue. Ah, I see. Angle sensor also not connected. Ah, I see. That's true. That's true. We basically had minimal cables on, so uh, it almost you almost think you still don't have backlight because it's so
Yeah.
dark. Uh, wait. Are we okay? We're waiting for the continuous screen option. It didn't go through. Okay, let's do back. Not now. Uh, you see this. The cables, the antenna cables are not connected, but you're still able to pick up the Wi-Fi. Then the other device we worked on. What was it? Um,
2020.
yeah, with that one, it did require. Okay, yeah,
Wi-Fi
yeah.
antenna to be connected.
Okay, so let's the fact that we have 14 point something volt on our backlight, that is great. So what we now want to do is let's see, do we need to? Okay, so let's connect the keyboard and let's connect the antenna cables. Power button is also not connected. Yeah. So let's connect the keyboard and so that you guys obviously will see that yes, we now have a fully functional backlight. Let's connect that. The angle sensor as well. Yeah, that wasn't connected. Our angle sensor. Connect that and then keyboard. Okay. Let's try again.
Yeah,
Now we have it. So that's a beautiful back. So now again, let's see what is it that we have on our backlight output still. So we still have 14.6. So initially, obviously, we were getting zero. It was just completely zero initially, but now we see that we have a back. But then also you did notice something that even though the multimeter says you have backlight, the voltage stays the same thing. There was no changes. Do you understand? Like it's still 40.6. The first time we checked, we measured was 40.6, even though the black backlight wasn't bright enough. Do you understand? And now it's still 14.6. I don't know if you understand.
Press the escape key.
I see what it is. So even the first time, the backlight was actually bright.
but when it comes to this,
Yeah. So oh, I see. Yeah, because I was trying to understand. Wait, but it's bright and it's 40.6, and it was also 40.6 and it's still. So yeah. So okay. Where's our mouse cursor? Wait, I don't see the cursor. Where is it?
now you connect the keyboard, so you can use to.
Okay, let's see. Oh yeah, I see. Aha. Oh, okay. Yeah, yeah. Now that the screen is on max, let's see. I actually didn't get what you were saying about the keyboard. Like, wait, what you saying? I thought you were saying I can nest using the keyboard. So on max, let's see what we have on max. 40.6. Okay. So so 40.6, 40.6, 40.6. Okay, great. So that is so why I wasn't saying the cost. I was yeah. So there you go, guys. That's the repair is complete, and there was somehow liquid made its way into the board and then found its way into that particular region. And then with the 16 inches as well as the 14 inches, one thing that we have noticed, it's oftentimes you find that liquid find its way into that section of the board. How? I mean, it's almost all the time that would happen to you. You find that liquid find its way to that section of the board. So guys, yeah, we needed to connect the keyboard so to help us increase the brightness, and that we did. So our replacements was our work was centered around here, which is the backlight IC. So like I said, there are multiple steps required when you're doing an actual troubleshooting of your backlight. But then for this particular design, because with Apple's with your Mac, depending on the type of device, that will determine what type of troubleshooting that you might, even though the issue is the same, it's the same across the board, but the cause of the issue may vary from device to device. Do you understand? And the troubleshooting steps you take. So because we're familiar with the failure of this particular one, that's why we just had to head straight to the section of the backlight circuitry. I mean, for other models or for other design, we may obviously not go straight to our backlight circuitry. We may take other steps, for example, check the enable signal and check that the MOSFETs are actually opening for the PV bus voltage to get into where it's required by the backlight chip itself. So all of that we are not doing here because of the particular design that we are dealing with. Anyway, this is now going to go this is now going to be assembled and then finalized, and then so you guys can see we have a fully functional backlight repair. Thank you guys, and then we didn't have to replace the actual backlight chip. Thank you guys. I will see you guys in the next one.